Okay, students, this should be a little shorter video than what maybe you've been seeing. I wanted to start off with what we had written down in class, that a tangent line is a straight line that touches a single point on a curve to show the steepness or the slope at that point. So here's what we're going to be doing. What I would like to do, and what you're supposed to be doing for this assignment, is to describe the slopes in each of these graphs. So we have 5 different graphs here, and I want to be able to describe the slope itself. So if we look at the first one here, this looks like the same kind of graph we've been having, like the tumble buggy constant velocity motion here is what we're looking at. So how are we going to describe that slope? Well, it looks like it's positive because it's sloped upward, and it's constant, meaning the slope's not changing. It has a steady steepness the whole way. All right. Now, what I want you to remember here is that the same words we're using to describe the slope are also describing the velocity. So, again, we're talking about a positive constant slope, which means a positive constant velocity, because remember, that's what the slope of the xt graph is. It is the delta x, or the change in position, over the change in time. That's what we're dealing with. So on to the next one. For the next one, though, we're going to need some tangent lines. Now again, this is the kind you just saw in the go-car lab. So let me see if I can actually draw some tangent lines on here. I don't know if it's going to work or not, but oh, that's not good. Let's try that again. Maybe right about here. That's not too terrible. And then maybe right about, oh, that's bad. Yeah, I was afraid of this. Whoa, that's the pointer, not my dang pen. Alright, here we go. Oh my gosh. I'm having as bad a time as I did in class. Okay, I guess that's decent. And that's at the beginning. And then the slope over here, oh, that's not too bad. So, here's the deal. Early on, the slope is not very steep. Later, the slope is much steeper. So how are we going to describe the slope? I would describe it as, first of all, positive, because again, it's tipped up, right? The tip up here means it is a positive slope. So again, we're going to say it's positive. Now, is it constant? No. Well, what is it then? We would say increasing. The slope is getting steeper, you see. It's increasing. Now, that means we're talking about the slope, okay, or the velocity. So that curve is telling us that we are having an increasing positive velocity because the tangents to the curve are getting steeper. I hope you're following along with that. All right, next one. Let's see here. A slope or a tangent at the beginning might look, oh, I tell you, I'm struggling. Trying to use a straight edge on an iPad, it's not easy. Oh, that's pretty good. That's the best I've seen. All right, let's see. Not quite, almost. Oh, that's not bad. So, what are we looking at here? Well, the first one I drew, the one closer to time 0, that's pretty steep. This one here, it's not as steep. So what's happening to the slope? Well, first of all, what kind of slope is it? Is it still positive? Yes, it's tipped up. So we're still talking about a positive slope. What is it doing? Is it increasing? No, it's decreasing. It's getting less steep. So it is a decreasing slope. Now again, we're talking about slope, but really we're talking about, remember, velocity. So this graph is actually showing a positive but decreasing velocity because it was steep at the beginning and it's getting less steep as time goes on. So this one started off not very steep and got steeper. This one started off steep and then started getting less steep. So decreasing, positive velocity. All right, next. Okay, let's see. How are we going to draw this? Let's see. Oh, that's pretty good. I got to tell you, that's pretty. Oh my gosh, that's terrible. Oh no. Oh man, I can't do. Oh, that's a shame. I can't just get rid of one of them. Oh man, that's terrible. There's nothing I can do about that. Well, I'm gonna have to try this one again. The laser. Oh my gosh, I swear. Okay, that's gonna be okay. And I gotta get another one. Oh geez. Let's try that again. That's pretty good. So, if you look at this one, early on, I wonder if I can move that. Whoa, not the whole thing. Forget that. So, the first line, that's pretty steep. This one is less steep. So the first one, closer to the 0 time here. Again, that's early on in the curve. That's steep, getting less steep. Now, how is it tipped though? It's tipped down this time. It's tipped down. These are tipped up, that's positive. These are tipped down, that's negative. So we're talking about a negative, and is the slope getting steeper or less steep? It's getting less steep. So we're talking decreasing. And again, we're talking about the slope. But hopefully you realize by now we're also talking about the velocity. So this curve is telling us that the velocity is starting off pretty large and negative because it's a negative slope, and it's getting smaller, meaning it's getting less steep, and therefore the velocity is decreasing. So this is a negative and decreasing velocity because the slope is negative and decreasing. All right, last one. Oh, let's see. At the beginning of the time interval, oh, that's terrible. It is, that's pretty good. Oh, maybe something I should do here. So this first one over here, it looks like it's touching at about that point. This one looks like it's touching at about this point. So these are the places that these tangent lines are touching the curve. So it's touching the curve here, and it's touching the curve over here. So I'm showing you this is early on. This is early on, it's very horizontal. Now, as we go further, let's get the blue pen back. As time goes on, it looks like the slope is getting, oh man, not quite where I need to be. Whoa, I don't know what just happened there. I guess that's gonna have to be good enough because I'm not gonna try it again. So that's touching at that point. So notice, what kind of slope did we have at the beginning? That's horizontal. That would be called a zero slope. And what's happening to the slope as time goes on? Well, that's steeper, right? But it's also tipped down. Steeper and tipped down, we're talking negative here. These slopes are negative on this curve. Negative slope. And is it getting steeper or less steep? Remember, it's starting off with no slope and getting steeper. So that means it's increasing. So we're talking about a negative increasing. Oh boy, running out of room on the screen. So negative and increasing slope, which again, that means we're talking about velocity. So I hope you're able to see and look at what the tangents to the curve are doing. Starting small, getting steep, that's increasing. Starting steep, getting smaller, that's decreasing. Starting steep, getting smaller, decreasing. Starting with no slope and getting steeper, that's increasing. And you have to know whether it's negative or positive based on which way it's tipped. So I hope that helps with how to interpret what's happening to the velocity in a position time graph using tangent lines on the curves. Hope that helped.